Hello and welcome back. We now discuss question number 3 from exercise 8.4. If x has Poisson's distribution with parameter m and probability at x equal to 2 is equal to probability at x equal to 3, then find probability of x greater than equal to 2, and we have been given e raised to minus 3 is equal to 0.0479. Now we know that for a Poisson's distribution, the probability function is, that is p of x is given by e raised to minus m into m raised to x divided by x factorial. Now we have been given that probability at x equal to 2 is equal to the probability at x equals 3. Now this condition has been given to us. Now using the formula for p of x on both the sides, let's see what we get. So we get e raised to minus m into m raised to x, x is 2 upon 2 factorial, and on the right hand side we get e raised to minus m into m raised to x, x is 3 divided by 3 factorial. Now e raised to minus m and e raised to minus m gets cancelled out on both sides. So here we have m square upon 2 factorial is 2 is equal to m cube, and 3 factorial the value is 6. And we simply cross multiply, we get 6 over 2 is equal to m cube upon m square. Simplifying this, we have m is equal to, now this if we reduce we get 3. So the value for m, that is the parameter m, is equal to 3. And now we have to obtain the probability for x greater than equal to 2. So probability of x greater than equal to 2. Now greater than equal to 2 implies probability of x equal to 2 or probability at x equal to 3 and so on, right? But we know that for discrete distribution, sum of all the probabilities, that from 0 to n, the sum is equal to 1. So instead of finding probability at 2, 3 and so on, what we do is we find it as 1 minus probability at x equal to 0 plus probability at x equal to 1. That is 1 minus the remaining. So the remaining probabilities are 0 and 1, right? Starts from 0. And we require the total from 2 onwards. So 1 minus p of 0 plus p of 1. Now let us apply the formula for p of x. So we have e raised to minus m, m is 3. So we have e raised to minus 3 into 3 raised to 0 upon 0 factorial plus e raised to minus 3 into 3 raised to 1 upon 1 factorial. Now e raised to minus 3 could be taken outside as a common factor. So we have 1 minus e raised to minus 3. Now within brackets we have, now 3 raised to 0 is 1, 0 factorial is also 1. So we have 1 plus 3 raised to 1 is 3, 1 factorial is 1. So 3 divided by 1, that gives us 3. So we have 1 minus 4 times, 1 plus 3 is 4. So 4 times e raised to minus 3. Now we have been given the value of e raised to minus 3. Let's check. E raised to minus 3 is 0.0497. 0.0497. So if we perform this multiplication, 0.0497 times 4 gives us 0.1988. 0.1988. And finally, if we subtract with 1, we get 0.8012. We have 0.8012. So this is the required probability.